Linear logic. This presentation is being completed by the team with all members including as follow: Valentín Báez Trejo, Berenice Torres Chávez, Marco Antonio Medina Sotelo, and Francisco Barbosa Ramirez. Content. What we're going to present next is going to be the content, and it's going to be shown as follow. First, we're going to have a brief introduction, followed by the formal components and his syntaxes. The next will be the structure of well-formed formulas. We're going to have the rules, axioms, and theorems. After that, we're going to have the implementation, followed by the cons and pros of linear logic, as well as the application of linear logic. We're going to compare linear logic with other logics, and finally, we're going to have our conclusions. As far as introduction, linear logic was introduced in 1986 by Girard as one way to extend classical logic. This is going to be the same classical logic that had preposition of true and false. But now, with linear logic, we have a different view. Linear logic will propose that there are more prepositions of true and false that can be also be taken in consideration. For example, there can be prepositions that can be consumed. Now, once this preposition has been consumed, it can no longer be on the same context. Now we're going to continue with another example. This example goes to classical preposition, and we're going to have A and B as premises, where we have A as a cloudy day and then we have B as a may rain premises. So in this example, we have that A and A then B. It could be possible, and it can still keep A as part of the result. What we see on this example is that in classical logic, we can keep both premises, A and B, even after getting the result of the preposition. Now, in this new example, it's very similar to the previous one, but it's going directly to linear logic. We have variables A and B, and we have A equals to, I have $8, and B it's going to be equals to, I have a coffee with the value of $8. Once we apply the rule, we have that the result of I have a coffee of $8 will implies that variable A, I have $8, it's been consumed, and therefore we can no longer use this variable in the same context, leading this to having only one final result, which is going to be variable B, I have a coffee with a value of $8. Linear logic should not be considered as a new discovery type in logics. As was mentioned by Girard in 1995, linear logic should be seen as an extension of the classical logic. It's just that have new connectivities. This is something that had mentioned Girard in 1995. Now, in this new way of using hypotheses as part of conception will help and will give a new approach to those constraints that had the classical logic. On top of this, we can also mention that linear logic will allow new prepositions to express the domain in a better way. On this new slide, we're going to have a table with all the connectivities that we can find in classical logic and also what we will find in linear logic. Some of them that we can introduce as far as linear logic, we have the multiply and, the multiply or, which are connectivities that linear logic have added. Also, we have adding and adding or, as well as the exponential. These are some of the examples that linear logic have added to the connectivity chart that we can see on this slide. Well-formed formulas. On this new slide, we can see that linear logic has been using pretty much the same structure that classical logic is using on his well-formed formulas. Now, linear logic has add new connectivities that may change a little bit what we have on classical logic, but pretty much the foundation of the well-formed formulas, it's based on the classical logic. Rules, axioms, and theorems. This is going to be the presentation of the table with the connectivities of linear logic. Between all these connectivities, the ones that we can mention as new or being added directly by the linear logic will be the following: multiplication and also multiplication or. We have two more connectivities that are similar to this ones, but we'll be adding and adding or, as well as the exponential, as you can see on this table. Rules, axioms, and theorems. The inferential rules are the foundation of the inferential operations. Due to the motions where you can have one or two proof formulas and you can make a third one. This is the basis of the axioms and theorems. Now, as far as the axioms go, we can say that pretty much linear logic has followed the same axioms as the classical logic. It's important to mention that Okada had an important contribution part when his work helped to complete the following axioms. Now on this new slide, we can see that linear logic have introduced some actual equal logic observations. From them, what we can remark is that we have expressions like A equals B. And some of the interpretations that we have in linear logic, we have that A refers to B, adding times B refers to A. These are some of the most common that you will find in linear logic. As far as theorems, what we're going to see on this new slide, we have divided in two groups. The first group, it's about semantic, and it's basically going or referring to the probability as far as the base of linear logic. Since this has been used to present some of the properties that linear logic has, for example, indivisibility, elimination cut, and the fragment divisibility. The second group will be the concurrent calculus. Since this has been introduced as a generalization of the concurrent constraints, where the process can consume information due to the petition of operations, as well as it synthesizes the evolution that has been tested on some of the functional programs that have been done. Now, what we're going to have, it's an example. This is one simple example of one of demonstration in linear logic. What we're going to have here, it's A and B, a negative A and B implication of an actual negative B and its negative A. Next, what we're going to do as a first step is we're going to be using the rule of the negative linear to the right. Now for the next step, once we have the result, which is going to be this one marked in red, we're going to be using another rule. This is going to be the rule of interchange to the right. And now on this slide, we have the result. This is in red, what we got from the previous rule. Again, we're going to be using a new rule, and this is going to be the rule of inference to the right. And as we continue, we're going to show the next result. Again, it's in red, applying the previous rule. Moving on, the next rule is going to be this one. This is going to be the actual negative lineal of inference, but going to the left. We continue with the example, and now we have the result in red again of the previous rule. Coming on with the next rule, we're going to have this rule as the inference of pair. will help us to pair variable a and b. Now, as we can see, the next result that's in red again, this is almost the last result. We're gonna see a new rule. This is gonna be the new rule we're gonna be using to get the final result. This is gonna be the actual inferential implicator lineal, and it's going to the right. So now we have the last result, as we can see, having a and b negative, implying negative b and negative a as our final conclusion. Okay, now the next slide, it's about the pros and cons of linear logic. And what we can say about this is that pros and cons will be depending on the actual context that we'll be using. For example, one of the pros that we can find in linear logic is the resource of the consumption. Remarkable pros that we can actually state it as a clear inference of linear logic will be storage and also applications with parallelism. Applications of linear logic. Well, nowadays, time and technology improvements allow linear logic to put all this knowledge into action. Along with the benefits that we receive, we can mention some of the influence in our world. As an example, we have prolog programming that had been influenced dramatically on his structure. Another example that we can present is the internet. Since the first appearance of it, the influence of internet that had in our world, it's been overpassing the limits. The good thing about this is that linear logic has been playing an important role on TCP and IP protocols. And as a finally, the last example, but it's more familiar to us, it will be the cell phones. Technology and those improvements have made those big changes on cell phones as what we have today, and our actual screen interface is where the linear logic can be applied to. Comparing linear logic with other logics. It is hard to compare logic, especially when classic logic is just like the father of the logic. Of course, there's been new discoveries, new contributions, and it's been adding new values to logic. So I guess that more than comparing linear logic with other logics, I would say that it's more about the contributions that each logic has added to the classical logic. Conclusion. As we have mentioned before, time is important in different aspects, but in the specific to linear logic, it's been an important factor since it was confirmed and was consolidated to the impact that it had made to logic. As part of this presentation, we can conclude that linear logic contribution it's been made along the way on each single improvement that we have right now in our times.